And welcome to another reactions video. This video will cover another alkene addition reaction, and it will specifically have to do with peroxides and hydrohalide addition to alkenes. Now this is similar to one of the previously mentioned reactions, the hydrohalidation of alkenes. However, in this one, peroxides are added, and peroxides are special because they can generate free radicals, shown in this mechanism here. A free radical is nothing but just a single electron floating around. So instead of having an electron pair associated with an atom, you will have a single electron associated to it. So in the case of this oxygen, they will still have, the other electron pairs, but they'll still have this single electron, which is why in this free radical mechanism you use a half arrow. They're called fish hooks because they're missing half of the arrow, and it resembles a fish hook. The reason that these are used is because only one of the electrons move, so you can imagine that two of them will have a full arrow and one of them, as half of two, will have half an arrow. And so this is just a basic peroxide. Any type of R group would suffice here, and then that would happen, this bond would split, one electron would go and associate with this oxygen, and one electron would associate with this, creating two identical free radicals. Now, free radicals undergo three steps when used in reactions. These are the initiation step, the propagation, and the termination step. So the initiation, you can imagine, is when the first bond is broken by the creation of the free radical. So that's when the peroxide here splits. And so you have A and B, which is linked by a single bond, which will have one electron associate with A and one electron associate with B. This usually happens by heat or light, and will create this. Now, propagation steps are the most frequent and should be where the end product is created, not from the termination, even though it might sound counterintuitive. But the reason is because propagation happens a lot more, and you can expect a lot more propagation to happen inside of your reactions, and you cannot rely on termination, or else you'll get very low yield of your desired product. So the propagation is when a free radical will cause another single bond to break, which will form a bond with this A and this C here, with single electrons from each, and this bond here will have one electron associate with the D, and have one electron associate with this AC single bond, and A will also have one of its electrons associate to make this bond, which is why the product is AC plus D. And so this can go on forever, which is why you want your product to happen in this. So you can end up with D, E, F, and the same thing happens, etc. And the termination step is when you have two free radicals come together. One of the electrons from one of them will associate here, and this one will move here, creating a bond. And then you end up with this FG system. So now, this is the overall transformation for a free radical hydrohalide addition. You have here an alkene and a hydrohalide. But if you use a peroxide, any peroxide, here's benzoyl peroxide used just to initiate, you'll end up with this final product. Now the important thing is that this is anti-Markovnikov. We learned earlier that the Markovnikov rule states that the bromine should actually attach to this carbon, so the product would have bromine on this carbon. Oh, sorry, I meant on this carbon. On this carbon bromine should be attached and not the hydrogen if we didn't use peroxide. However, now because we do use peroxide, the major product will have its bromine attached to the terminal carbon here. And as I explained, this is the situation. Oh, another distinction is that the addition of peroxides makes the reaction go far, far faster than if you have no peroxides added. And this is the overall change. If you have here, for example, an alkene with two R groups on one of the carbons and two hydrogens on the other, what will happen in the HBr, so without peroxide, is that you'll have the hydrogen, associate with the terminal carbon here on this side, and the bromine will attack this one afterwards because of the more stable carbocation and things discussed earlier. But in the peroxides, this variation will occur. So this is the general mechanism for the hydrohalide addition with peroxides. And so yeah, the initiation step will always involve your peroxides. The peroxides will have their single bond dissociate and create two of these free radical somewhat peroxide, I guess. So that's the product from them. And these are the propagation steps. So as I said previously, the propagation steps should always include the final product that you're desiring. So in this case, you have some of these will react in order to form multiple free radicals, and they will just keep propagating. But this is the key one, is that you will have your halogen attack the double bond before you have the hydrogen attack. That's the reason that these two different products are different, is because in this case, the bromine will attack first, which will create the carbocation here. Well, not the carbocation, it's a free radical, but it's still the more stable free radical. And in this case, the hydrogen will attack first, which is leaving a carbocation in the center, and the bromine will attack it. And so therefore, you have your end product here listed at the end of the propagation steps, and it comes from a reaction of a free radical together with another hydrohalide, such that the hydrogen will bond to it and the halide will dissociate and continue propagating or terminating. Really depends. Yeah, thank you for watching.